be 20. And then also contact status, start from previous, that's what we want. And initial penetration gap, we want that to be set to 0. Okay, so once you have all that configured, you can click OK, do everything. And now under the simulation navigator, subcase 1, static loads 1, we want to rename that to be preload only. Okay, now we're going to define a contact. So here's the important thing that Jared was talking about. If we hide so 3D collectors, if we hide solid 1, or actually solid 2, actually all the geometry. Let's see. Okay, let's hide all of this. Okay, so here we are. We hide all of the meshes, and then we hide this first guy. So all we're looking at is the rod. And we want to define a simulation object type, a surface-to-surface contact. So here's surface-to-surface contact, which Jared explained is nodes are attached to each other directly. And surface-to-surface gluing is, right, this is for two surfaces that are close, but the nodes don't have to line up necessarily. So we want to do a surface-to-surface contact, and it asks us type, we want to say manual, and so it says source region. We're going to click on create region, and we want it to be this red part right there. And once that's done, we hit OK. And for target region, now we want to hide this guy and show the other wheel. And so we will create a target region on this surface of the wheel. Okay. And I believe, let's make sure that looks good. Oh, right, actually, on this target region, on the second one, we want to put an offset right here of 0.05 millimeters. So what it's doing is, it's going to, instead of just having the contact on right where the surface is, it's going to offset it +5, so inside that ring. So the tutorial explains this will simulate a 0.1 millimeter press fit on the diameter. So in other words, the ring here of the wheel is going to be a little bit smaller than the rod. And okay, so that's what we want, and we can click OK. And now it made, you can see it made that surface-to-surface contact. Okay, we want to put constraints, so we will just put a fixed constraint, and it asks us to do it on this surface here. And I believe that's all. Okay. And then it asks us to put another constraint, a user-defined constraint, and it tells us to put it right along the edge here. This one. So along this edge, we want it to be a, hold on. Right, displacement CSYS, we're going to say cylindrical. And right, and it's going to select this edge. Okay. And it asks us to constrain degree of freedom 2 and degree of freedom 3, which is translation in the Y and translation in the Z. Here we click OK. Now let's put another user-defined constraint along that edge. All right, now Okay, I think it's ready now to solve. So if we come down to solution 1 and say solve, it should run. And this one will actually be pretty quick. Are there any questions up to this point? I haven't asked. Tutorial's pretty straightforward. Follow along. Okay, it just finished. We can close out of these windows. And so if we look at our results, solution 1, it tells us to look at displacement nodal and magnitude, and it should look like this. So, right, that's what it looks like in the tutorial as well. So there's a button here that says return to model. We can go back to the model, and now we're going to put a force on this, or a new solution subcase. So if we go to solution 1 and we say new subcase, we're going to call this one preload and opening or operating. All right, so here's our preload and operating subcase. And we're going to put a force on here. So a force and type filter. No, type filter's up here. Let's see here. Just do it on this side. So if we select this polygon face and oh, here we are, sorry. So it's going to be a normal force. So type is normal. And we select this face here. And the expression is, or yeah, the magnitude is negative 5,000 newtons. And it asks us for distribution to be total per object, not geometric distribution. And we click OK. And now it's created a force tangent or normal to that polygon face. And so now that we have that there, we can solve it again. And it should, okay, take about just the same time, just another 30 seconds or to a minute, and it should come up with the result. And that is basically the tutorial. So that, all in all, should be pretty simple. Yeah, the one difference between last week and this week is that in this one you have to, when you have multiple parts, you just have to make sure you constrain them or have contacts, gluing or surface contacts, and then you can, you're able to run an analysis on on several parts, on a whole assembly rather than one part. And so as part of the lab, we want you to use the techniques from the tutorial and do a structural analysis of the control arm assembly. So in this one, you're free to figure out what constraints, what loads to put on this, find something that you think would be reasonable, and run an analysis. Make sure you just have the contacts together. The point of it is to practice that, learn how to get all that together. And then you can apply these FEA techniques to more subsystems of your vehicle, and you can see how they all interact together under one set of loads. So we'll look at this, cancel, close, and results. So if we look at the results of solution 1, load case 2, displacement nodal, magnitude, there we are. So there's that displacement. And if we go to stress, elemental nodal, to the von Mises stresses, this is what it looks like. So there's our analysis. I just want to show you a picture real quick if you'd like to see of something I did from last year. 10. Here's a picture of a nodal displacement of our front suspension that we were able to set up. So it was pretty, once we got all the connections, we had to put ball joint connections here, some pins and other things, and then put some forces on the end here and constrained it in the middle, and we were able to get a pretty good looking FEA simulation. So this is what ultimately you want to have, some kind of assembly level FEA for your car. And that's about all. Are there any questions now? All right, great. We will be here walking around, helping you if you have any questions on the lab or anything else. Those of you on Skype, I'm gonna hang up the call now. And if you have any more questions, go ahead and give me a call. All right, bye.